Welcome to the Climate and Coordination RCAST, where every week we'll be discussing topics related to all things climate change and RChain's role in the solution. We will be discussing technologies that can adapt and coordinate massive amounts of data like never before, forming social architectures that grow collective intelligence, sharing and evaluating data planetarily, all while maintaining personal privacy and personal data ownership. A new decentralized economy is forming as we move from the third industrial revolution, digitization, to the fourth, decarbonization. By building a co-op, built on a correct by construction, concurrent, scalable solution, RChain is structured to build out the new technology that will be required for a flourishing regenerative planet. Please join us on this journey.
Okay, great. So welcome everyone to this week's Climate and Coordination RCAST. We are very happy to be discussing different topics about technology and nature and other subjects that we feel are important and interesting for everyone to know about. So we have an array of those topics for you today. The first one is from CTV News, which I understand maybe Daryl can confirm. This is a Canadian publication. And the headline says here, climate change could push temperatures at the Tokyo Olympics to the danger zone for athletes. This is from June 7th. I was reading this piece about basically there was a report that was done by a group called the British Association for Sustainable Sport. And they were talking about basically the health impacts of the Summer Olympics in Japan, which is going to happen between July 23rd and August 8th. Sorry, there are some very loud birds outside my window, but that is great. Okay.
That's a good thing.
So yes, it is a good thing. They're adding some color to the conversation. So yeah, basically they've already had to move some of the summer events in Tokyo, like away from Tokyo, because obviously the city is going to be a lot hotter. So first off, the marathon is taking place, it says 500 miles north of Tokyo in a place called Sapporo, where temperatures are expected to be much cooler. And I guess they're also trying to get ready for just not only just spectators and the organizers, but the athletes themselves getting very sick from heat exhaustion and other ailments, which are obviously the risk of that is amplified when you're doing strenuous activity, especially the Olympics, where people tend to push themselves to the limit anyway. But in an extremely hot environment, that can be super dangerous, obviously. So it says, while the average high temperature in Tokyo during the Olympics late July to early August is 30 to 31 degrees Celsius, which is 86 to 88 Fahrenheit. They frequently experience high temperatures in the mid-30s, which is the mid-90s, and in recent years have approached 40 degrees Celsius, which is 104 Fahrenheit, which is extremely hot. This is a really fascinating little piece about this at the bottom of the article, and I was just fascinated to learn about, what they're planning to do with the Olympics, and I was also fascinated to know that there are people that are publishing official reports talking about the safety of the athletes and the safety of everybody. But what really interested me was this little tidbit at the end that just got dropped into here for context, but made me really surprised. It says, it's not just the Olympics that has taken searing temperatures into consideration. At the 2019 World Athletics Championships in Doha, Qatar, marathon runners toiled in 32-degree heat and humidity levels above 70%. Even after start times were moved to midnight. Okay, so they made these poor athletes, runners, do a friggin' nocturnal race, which is so cruel. And it says, in the women's event, 28 of the 68 runners who started failed to finish, and some had to be stretchered off the course. So you have people just collapsing in this heat, and it's at midnight. It also says at the tennis Australian Open, meanwhile, recent temperatures have been known to exceed 40 degrees Celsius, causing players to faint on the court. But can you imagine that? You train your whole life for this event. They choose an incredibly hot location. they say, okay, great, well, that's fine. So we're just going to start the race at midnight, which I'm sure puts an enormous amount of anxiety and strain on everyone. And then it's still so hot that people are passing out during the race. It's just so cruel to do this to people. And I'm really hoping that there isn't going to be some kind of medical emergency in Tokyo, but I would love to know if anybody has any comments on this story. I just thought it was really interesting that they're talking about this.
Well, I'm going to book my ticket for the 2054 Olympics in Northern Greenland. It'll be good.
Is that a
Hey,
joke?
look, I well remember a guy. I well remember this guy back in, I think, 1960, because athletics is my sport. That's what I used to do, track and field. And there's this guy, I think his last name is Matthews, and he was a race walker. So he's one of those guys that do kind of like the funny walk. And the Olympics that year were Tokyo, and it was going to be really hot and humid. And so he spent his training time, he spent loads of his training time in his bathroom with all the hot taps running, just walking up and down his bathroom. I mean, one of the amazing things it does show is how the competitive spirit remains undeterred. It's just a shame that they have to face conditions that are due to man's activities.
Yeah, we'll say human activities on that. But
Human
yeah,
activities,
I just
yes.
think, yeah, I mean, it is amazing to challenge people to overcome extremely difficult circumstances, but it's sad if it's going to like potentially harm their health, you know? I mean, I was at Wimbledon one year and I passed out from the heat and I woke up in a little tent hospital with people taking care of me, which was wonderful and free, I might add. But I mean, heat exhaustion or heat stroke or whatever. I mean, I know there are different levels of severity there, and I can't remember which of the ones is the most severe, but it's really terrifying, you know, and it can, especially, you know, it can like affect even a very healthy person. And I don't think it's good for your body to be passing out from heat exposure. I'm not sure what the long-term effects of that are, but I don't think it's fair to have to ask our athletes to do that. I agree with you, Steve. So we'll have to see what happens, but it's possible that the Olympics won't be able to take place in hotter places, or at least at the hotter times.
They need to address that, because when they awarded the games to Doha, for instance, that was when they changed, it was the World Championships in Doha. Yeah, the marathon also had to be run at a ridiculous time because it was too hot. But that's down to the IAAF and the IOC ensuring that they need to ensure the safety of the athletes. And that needs to be paramount more than the franchising and the money side that drives Olympic bids and who gets awarded a games. They need to take that shit seriously.
Yeah, absolutely. So I just thought that was a really fascinating story. But here's another one. This is a little bit sad and distressing, but don't worry, because there's a third story that's a happy one. So it's not all doom and gloom today, thank God. But the second one I wanted to talk about, Steve, you were just mentioning this a bit ago. This is from The Guardian, which continues to remain one of the most consistent and reliable sources for extremely well-researched climate news that I have ever seen. So I just want to say thank you to The Guardian, if anybody from The Guardian is listening to this. Okay, the headline here says, climate crisis to shrink G7 economies twice as much as COVID-19 if temperatures rise above 2.6 degrees Celsius. So it says here, this is written, by the way, from Fiona Harvey, who is an environment correspondent and someone whose work we have discussed on this podcast before. It says here, the G7 countries, the world's biggest industrialized economies, will lose 8.5% of GDP a year or nearly 5 trillion wiped out of their economies within 30 years. That's 5 trillion per year. If temperatures rise by 2.6 degrees Celsius. And this is research from the Oxfam and the SwissRe Institute. It says the economies of the G7 nations contracted about 4.2% on average in the coronavirus pandemic. And the economic losses
from the climate. Way more important. It's not the SwissRe Institute.
Oh,
SwissRe is the biggest reinsurance company in the world.
I see.
This is an insurance company saying this.
Oh, okay, yeah, that's great.
Huge.
Yeah, it's great to point that out. Yeah.
And SwissRe, because they're a reinsurance company, they drive the rest of the insurance market.
Yeah. Yeah. So, thank you for pointing that out. So, let's see here. Where was I? Oh, yeah. It says G7 nations contracted about 4.2% on average in the coronavirus pandemic, and the economic losses from the climate crisis by 2050, which is less than 30 years away, would be roughly on the scale of suffering a similar crisis twice every year, according to the research. And then also it breaks down that the UK would contract probably a little more. India would contract the most, I think around 12%. Australia would, and South Korea and a few other nations would contract larger than the US for, I'm not sure what reason, but I just am like so interested in, why the discussions about, financial markets and, long-term economic policy, like very rarely discuss, firstly, how to limit risk in financial markets and the economy based on the climate crisis and research like this. And number two, how to use capital either individually or collectively to slow or to stop the climate crisis. Obviously, as I wrote in my most recent blog, our concerns are not just economical. I mean, I think it's important that we understand that Earth has value, regardless of what human beings are doing with that value. But it's just crazy. Like, this is a staggering, I don't even know what you call this, a report, a warning. I don't even know. Of course, 2.6 is quite high for temperature rise. There's still a chance that we could stay to 2, or like if a miracle happens, maybe we could stay to underneath 2 degrees Celsius warming. But it's very possible that we could warm 2.6 degrees. So hopefully this is not going to happen. And hopefully the financial impact of this entire situation is not going to be as bad as they say. But I want people to understand that it's very possible that it could be this bad. And also just wanted to say that they're meeting now starting today at the G7 summit. And they're talking about climate as one of the main topics, which I know you said before, Steve.
But the thing is that, like, if you pair all the other articles that have come out over the last 2 years with regards to measuring, our models against what's actually happening. Just recently, I read an article in which the sea level rise was more than twice what all the worst models had predicted. So I think the likelihood that we're going to blow up too is extremely at this point. Mr. Doom and Gloom here, but
yeah,
there's some optimistic turn is not not likely.
Well, still, I'm going
I
to
still say that
optimistic. Go ahead, Steve.
Yes. So I was going to say, I still think what makes this article actually quite mind-blowing is the fact that it is SwissRe, and it's not just SwissRe; it's their group chief economist at SwissRe, and he's the one saying, for instance, that COVID-19 was a key way to helping developing countries as their economies were hit hard by the pandemic and would need to help recover rather than through boosting fossil fuels. I mean, that's him saying that. And he was probably responsible for that modeling that the company did. And for a company like SwissRe to come out with a report like this has a massive impact on all reinsurance and all insurance. And then that has a knock-on effect on a whole bunch of other things, because all those insurance companies ultimately put a lot of their money into investments. So this is actually a really quite, I'm surprised I didn't see this article, because I do actually read The Guardian. But I think this is actually much more significant than even the article may realize. I mean, I know one of the guys on the board at SwissRe, who's a personal friend, not because it was anything to do with work. So I know how they operate, and they're Swiss. They don't do things that quickly, but they do them thoroughly.
Yeah, I agree with you. I think it's really important to think about the sources of these reports, and how measured or how conservative or how doomsday they tend to be in general, because that can also really have a big impact on what they publish and sort of when. But yeah, it seems like from what you're saying that this report is very consequential, and they're not operating on a hunch if it's reinsurance.
No, and as a result, as capital flows around the system, as a result of this, think of this as somebody dropping a stone into the pond, right? Those ripples will go through. One of the effects of those ripples is it will release more capital to deal with things like climate change specifically. So it will result in more innovation and on multiple levels. Because it's in everyone's interest to do so, because the insurance market is telling them.
I certainly hope that that's the case. My concern is that this become the reports like this from insurance
we shall see.
Yeah, well, but I hope it isn't the case that reports like these from the insurance companies means that they're going to renege on a bunch of policies, and right, because these climate change is act of God.
I think renewals will become a little tricky. No, I think renewals will become tricky. What you'll see is a change in renewal terms. So whilst you're insured at the moment, it doesn't mean you'll be insured for a particular event in the future. And that will result in people migrating.
Yeah, they could just do what all the health insurance companies in America do and basically provide you insurance and give you absolutely no coverage for basically anything. They could say, oh, well, we'll cover you if your head is half severed in a guillotine in, some, they'll give you these insane, circumstances under which you're covered, which you would never face in your life. And they'll say, look, now you have insurance. And it's like, that's what could happen with a lot of this situation. But there is hope. Greg, talking to you.
All right.
This is the third story that I have. And then after this, I'm going to invite Steve to share what he has prepared for today. But just wanted to say first, another report from The Guardian says that the Keystone XL pipeline has been canceled. It's been formally canceled. The company TC Energy has withdrawn the project totally. So originally, President Obama had revoked the permit for this, and then President Trump reinstated the permit, and then Biden finally revoked it a second time, at which point, after a decade, or actually more than a decade of protest and political pressure and press and all of this, and environmental activism and Native American activism and just huge pressure, they've basically just said, screw it, we're not going to do it, which is really good news. I think this is a huge win for the earth. And I'm very happy that this project is now finally over. it says here, TC Energy said it would continue to coordinate with regulators, stakeholders, and indigenous groups to meet its environmental and regulatory commitments and ensure a safe termination and exit from the project. What I don't understand, I wish they would talk about this more here, but if the pipeline hasn't really been built, I wonder what the environmental and regulatory commitments could be. Like this, it says here, safe termination. So I'm wondering, like, what have they done already to the land that requires safe termination? Because it seems like there already is certain infrastructure in place that would have enabled this project to happen. But I wish that they would talk about that more. And I was trying to find out more about that, but I couldn't find a good source. But obviously, you know, that there's a lot of, I guess we could say, pre-production that goes into these projects. So it's not just like, oh, we're going to build a pipeline. Oh, I guess we're not going to do it. I mean, I'm sure there's enormous amounts of materials. And I know it says here that actually, it said in a different article that there were like rows and rows of these pipes, empty pipes and pieces of pipes that were, you know, going to stretch for miles long. And they were going to, you know, obviously be put into commission. But so they have to move all these pipes, which have probably been sitting there for years and years. And so I'm sure there's a bunch of supplies that have to be moved. And just the last thing I'll say was that the Keystone XL pipeline was supposed to bring oil from Canada's Western tar sands to United States refiners. And the key permit that was needed for this stretch of the land in the United States, the northern United States, was 1,200 miles. I understand mostly over I think Dakota, or the Dakotas, but I'm not exactly sure. But anyway, so I just wanted to say that activism and protest are really effective, you know, long term, and sometimes they can solve big problems like this. And the other thing that's great about it is that I think it really shows that, you know, these projects are really hard to do. Like if you own one of these companies and you want to do a pipeline, I think it's important that those people know that there's going to be formidable opposition. And I think, you know, this one being finally canceled after having such a long fight, I think it really shows that long term, this stuff is not going to be successful. So, yeah, I think this is a good news story.
Yeah, I wouldn't want to negate the power of protest, but I would say that market forces probably were a huge part in this decision as well. I mean, the Alberta oil sands is the dirtiest and most expensive way to extract oil. And I'm surprised that fracking didn't destroy the pipeline first. It's amazing it survived this long, actually. But I would say that I'm going to guess that renewables and decisions like BlackRock's over the last year probably was the nail in the coffin. But I'm sure the protests didn't hurt either.
Yeah, no, I agree. I think it was a collection of forces. And I was just reading a piece about how with, you know, there's certain oil companies, big oil companies that are facing, you know, new regulations, new board members, you know, they're under new pressure, I guess you could say, legal pressure to change the way they do business. But for every one of those oil conglomerates that goes down, if they ever actually do go down, I think the price of oil might have increased this week, but there are going to be other companies that crop up, you know. So I think it's important to remember that, like, this might be kind of a whack-a-mole situation for a while. The whole oil industry is not going to, you know, collapse at once, but it seems like there are going to be quite a lot of fights like this long term to finally, you know, change the way the world gets its energy. I don't think it's going to be necessarily as quick as we would like to believe. But anyway, Steve, I know that you have something you'd like to present. So would you like to do that now?
Yeah. So a little while ago in the board meeting, we were discussing things. We came up with an idea. What we really needed to do was to talk about RChain and its use. in terms of the true cost of public blockchains. So that incorporates all the energy that's used to power a blockchain. So instead of talking about how much it costs to mine or a validator in terms of their capital outlay and their onward running costs in terms of electricity burned, we can talk about the efficiency of blockchains in terms of the kilowatt hours they consume against the number of get a better measure. So this is the abstract for such a position paper, and there's a very important part as part of the analysis. Right, what we want to do is provide an open ratio of terawatts per year consumed against the number of actual and projected transactions serviced in the same period, and potentially to provide a measure based on BTC's consumption and transactions per year. So you can think of RChain as being perhaps 0.00001 BTCs in terms of how it measures in terms of consumption, right? So, and it might be that Ethereum is half a BTC because it consumes about half, that sort of thing. So we're going to put some real numbers behind these things. And I found a bunch of references as well, which I've actually opened, and which I'll show you very briefly. So this one is Cambridge University's Bitcoin Electricity Consumption Index. So the total electricity production, Bitcoin represents 0.41% globally, right?
Whoa.
Yeah, it's quite a big,
Wow.
right? And then you've got things like this, right? So if you had hydro, so all the hydropower in the world could power Bitcoin's network 41 times. So they haven't used that much that they've used all the sustainables, but these are giving very interesting measures. So this is one, and then I'll show you another one. So that was Cambridge University. This is Wired. So Ethereum is slowly moving to proof of stake. Is that good news for climate? And this also talks about some of these, you're essentially talking about proof of work. So I won't go into the details, but, and it's trying to put some numbers behind it. And then of course you've got Bill Gates, who sounds alarms on Bitcoin's energy consumption. And this is from Forbes. And he gives some numbers too. And then you've got the Digiconomist with Bitcoin's energy consumption index. So you can have a look at some really interesting figures here, right? How about that? I mean, this is the carbon footprint. It's comparable to the carbon footprint of all of Morocco. I mean, that's an interesting measure from a carbon footprint. Single Bitcoin transaction, right? A single transaction is worth about 748.61 kilograms of CO2, which is quite an interesting number. So purpose of talking about this here is clearly this is about climate change. This is about sustainability in this forum. And this is about the role of blockchain in providing that or working against it in the case of things like Bitcoin. And a call to arms to anyone that wishes to out there that listens to the podcast that has something to say about the energy consumption of public blockchain networks, because we want to provide a very open way of examining that and telling the truth about really what gets consumed and how efficient Bitcoin blockchains can be. So it's a call to arms. And Greg is involved in this intimately too.
Yes, I mean this is precisely the sort of thing that should appeal to much of the blockchain culture, right? The blockchain culture is techie, it's engineers, it's scientists, computer scientists, and the like. Yeah, I mean, there are a lot of speculators out there, but the core of the culture is made up of people who believe in science and appreciate the application of the scientific method as a part of discourse and debate. And so this is I'm very encouraged that this culture will respond to reasoned argumentation as opposed to other cultures which don't appreciate this kind of debate. So I think if there will be several groups that spearhead the discussion and sway sentiment to move, which will then in turn move development in the right direction. That said, I actually also have a little bit of a presentation. It's
Fantastic.
it's at a different level. It's just five quick slides, but I need to quickly switch devices. So I'm gonna log in to this Zoom room again and then get off from my phone.
Okay, great.
So 1 second here.
Perfect. So Steve, thank you so much for that.
That's all right. And whilst we're talking, whilst waiting for Greg to come up, so as you guys know, we're working with a well-known photographer. I can't name that person on this because we're recording. So a well-known photographic library with some iconic pictures. And the people that own those photographs, who we're working with towards kicking off a proof of concept, this paper that we've just talked about now, and they actually want to go quite public on not just why RChain is great for doing their digital asset management of this huge library of photographs, but also why it's imperative that people should put more applications on RChain because of its sustainability credentials. So
nice.
We may even, should we get to the point where we kick off the POC and go public, one of them might tip up to one of the climate change calls.
That's great. Wow, that's great news, Steve.
More when I know more.
Very cool.
Aha.
That's really really good news. So and oddly, I think it, a lot of these things fit together in a certain way. I wish I could provide a better segue, but can you see the screen?
Yeah.
Yep.
So let me adjust it to be full screen. So yeah, sorry, this is still work in progress. So about 2 years ago, I gave a talk on RCAST called Towards a Living World, in which I looked from a purely computational perspective on what would go into living agency. So if we were going to model computationally what we thought living agency was, what would that look like? And just completely intuitively, I settled on metabolism and reproduction. Those were the two ideas. And then I gave an extremely concise row calculus interpretation of what metabolism and reproduction would look like, as a class of row terms, and what the behavioral types would be that would identify those terms, and talked about how how there was this deep connection between that model and the Casper model of consensus. So that there was surprising. I mean, for me, it was completely surprising because I was not thinking about consensus at all. But then I wrote down this idea and was quickly able to identify a whole bunch of structural features that were correlated between a row calculus implementation of Casper and a row calculus representation of metabolism and reproduction. Now, just a few weeks ago, I just randomly stumbled on a talk by Eric Smith, who is one of these wunderkinds. He was a fellow at Santa Fe Institute and holding academic positions, in many places from if I recall correctly, Chicago to Tokyo, and he gave this really astonishing and very well reasoned argument for the nature and origins of life. And I recently picked up his book called The Origin and Nature of Life on Earth. And I'm just going to give just like the cartoon image of what he's arguing. So essentially he's arguing that if you take geochemistry and you push it far from equilibrium with the energy from the sun, then you get life. And he says that more or less this is inevitable. Now, more specifically, what he says is that you'll get metabolic processes, which are in fact surprisingly conserved across all living organisms, that you find in all living organisms the same core metabolic processes that then inform how they accrete complexity. And I was just astonished that his argument was so similar to what I came up with from first principles. He argues if you just follow the geochemistry and in this using the regime of systems that are far from equilibrium and notions of phase transition, that more or less it is inevitable that you get metabolic processes that are then connected to notions of reproduction, which is a way of accreting the kind of complexity that we see in, and then at a certain level, then natural selection begins to have a foothold. So that's that to me was a really, really powerful affirmation of the line of thinking that I was taking, especially because, it's not just Smith, but Smith has a collaborator on the book and a whole community of climate scientists and geophysicists and geochemists and microbiologists who all, are sort of moving in this direction in terms of their understanding of what constitutes living in the world. But one of the things that's very interesting to me is that if you can give a completely computational account of metabolism, then you can sort of free Smith's argument from its geochemical context. And you can use bisimulation, or the notion of equivalence in the mobile process calculi, to see if you can find other processes in other embodied, sort of physical chemistry kinds of situations or settings, to see if they also have lifelike properties. Right. So this is one of the things that's really powerful about the mathematics that's at the heart of RChain. And really what we're suggesting is that bisimilarity is like a microscope or a telescope, because it allows us to look out across the processes in the physical world. In a way, it's like X-rays, right? Like before we couldn't see certain things, and then we discovered this use of X-rays, and then we could see kind of on the other side of skin, right? And by simulation and by similarity has a similar kind of, it gives us a tool to see into the skeletons of certain kinds of behaviors and processes, which would then, if we could lift this notion of life up into a computational account, then we can start to see life in places that we could never see it before. And so one of the most interesting things to me is that as the quantum gravity community moves closer and closer to proposals that they find viable, what we find is that the computational characteristics of quantum gravity are at a minimum Turing complete. They're actually more powerful than that. But what that means is that you could even potentially look at space-time itself as a ground in which you have all of the elements necessary to find living processes, to find metabolic processes, and potentially reproductive and natural selection style processes. So I'm not saying that there's a physical argument yet. What I'm laying the groundwork for is that there are steps, and mathematics that we can use to check and verify each of those steps, to be able to look out not just in terms of things like planets or stars or other kinds of matter energy configurations, but actually gravitational phenomena itself, right? So the wiggling of space-time itself is also a place where we might look using this telescope of biosimulation for what might be thought of as living processes. And what that does is it kind of shifts our perspective a lot, in the sense that, I mean, when I grew up and was exposed to the physical sciences, it was remarkably devoid of life, in the sense that physics didn't really hold in itself a place for life. And in fact, there are lots of conceptions in the sort of dynamical laws approach to physics and some of the other sciences that make many quantities essentially they're forced into being emergent quantities. An example, of course, is information. Information isn't exact in physics. It isn't captured by a dynamical law. It lives outside of that regime, and so can't be considered a part of fundamental physics in the current way of thinking about physics. And life is even way beyond the notion of information. And so what this view is suggesting is that in fact it's backwards. It's the other way around. That in fact life may be a fundamental property of space-time itself, and in the sense that space-time provides all of the computational nutrients, let's say, to give rise to what we would think of as living organization. And by the way, I'm not the only person to put forward this view. Christopher Alexander, who's a noted architect, in his sort of magnum opus, the Nature of Order, he also puts forward a similar kind of argument based on different principles, but a similar kind of argument that in fact the life is a property of space. So I just like this because it turns things around, and it makes our science more susceptible, sensitive to what is alive. And I think that if we're going to get through this knothole that is climate change, our very core concepts are going to have to shift and change. Our core concepts about what is life and its role in our experience is going to have to change. And so that's
the biggest biosimulation of all, this is conjecture on my part, is the Turing test. right? Because, if the point of the Turing test is that you can't tell whether it's a person or not, as we know it to be, as we know persons are, we can't tell whether it's a person or not. And if we can't tell, then to all intents and purposes, it is a person.
Yes, so that it's a very similar idea. I'm not at the point where I can successfully argue for reasoned agency, right? I'm not at the point where I can write down what I would consider to be, personhood level agency, but I am at the point where I can make some stumbling forays towards living agency, right? Some sort of halting toy proposals, and I'm shocked actually that there's a growing scientific community that shares this viewpoint. Yeah, that's a lovely equation, Ian. Yeah, it's really striking. Anyway, maybe this is I don't know, a little far afield from the Guardian article, but I feel like we have to change. We really have to rewire the way we think about what is alive, and how we want to engage with and respect living systems.
Yeah, I completely agree. And I thought this was very fascinating. Certainly a little bit farther out of my usual circle of competency, but I really enjoyed it. And I always enjoy, Greg, your ability to get normal people to think in new and interesting ways toward the future. So I really enjoyed it.
Well, thank you. That's kind of you.
Yeah. I am not really familiar with the concept of quantum gravity, so I just put a little definition that I found in the chat.
Yeah, well, one of the biggest issues in modern physics is that quantum mechanics and general relativity don't mix, right? So you have these two profoundly powerful theories, right? So accurate to 32 decimals or something like that in both cases, but you can't get them to work together, right? So you sort of have the theory of the very small and the theory of the cosmological, and no way to talk about what's in between. And so physicists, by and large, understand that somehow both theories are wrong. And this has profound implications. For example, Chiara Marletto, who has been working on a completely different approach to formulating physical theories called constructor theory. She points out that if we go very far down this path of basing quantum computing on the current presentation of quantum mechanics, then we know it's going to be wrong. And so this is going to have a big, huge impact on the quantum computing market and the quantum computing reality, because it's wrong. And so she suggests that there's a kind of urgency to finishing the quantum program, which means that there has to be some kind of quantum account of gravity. Yeah.
And does this, I'm sure this is a very Hollywood way to view this, but I have no choice. Does this have anything to do with what Stephen Hawking was trying to do when he was trying to make the theory of everything, or the equation that explains everything, or whatever exactly, however he said it? Is this related to that at all?
So theories of everything are in fact, about trying to bring quantum mechanics and general relativity together, right? So yeah.
But he never actually did that, though. Like, that's still something
nobody's done. Nobody's done, right? So
right.
Einstein struggled, Hawking struggled.
Yeah.
The string theory guys thought they were making huge progress, but they have, in the last 60 years, been unable to put forward a single experiment. Right, so 60 years of very high-powered math, and not one single experiment.
Yeah. Well, they just need a couple more weeks, Greg. 2 more weeks.
Just have to give a bump to Chiara's new book that it hasn't come out in print yet, but the digital is available. The Science of Can and Can't, or What is Possible.
Yeah, I've been listening to it myself, and I actually had an insight yesterday, and I understand now why she has been, because so I know a lot of her Oxford colleagues. Like I know Bob Cook, I know Samson Abramsky. I know these people personally, and so I was talking to Bob, and Bob was suggesting that she has been less motivated to investigate things like resource theory, and so I was kind of wondering why that would be the case, when I listened to David Deutsch's introduction and then her opening volleys in the book, I realized that they want to base physical theory on counterfactuals. And that means that they're lifting physical laws to the realm of modal logic. So they're suggesting that modal logic is the place where you would express a physical theory, because you're talking about possibilities, possible worlds, possible states that we can reach from here. And so that's a far cry from the dynamical laws approach to physics. So it's a very interesting. It would be a very interesting shift. But the upshot is that resource theory is at the wrong level. That would be why, intuitively, she would smell, oh no, this is not quite right. You'd have to give. There are categorical models of modal logic, but they're at a different level than resource theory. Anyway, we have 1 minute left. I really appreciate everyone's patience to let me talk about this stuff. There'll be a tie-in with Casper. I'll give a similar kind of presentation in the Casper stand-up. But thanks for listening.
Oh man, that was amazing, Greg. That was really amazing.
Yeah, thank you, Greg, so much for that wonderful presentation, and thank you, Steve, for your presentation. I can't wait to see what happens with that paper that you're writing.
Yes, send it to the address you're about to tell everyone. Send any comments to that.
Oh, the climate@rchain.coop email?
Yeah.
Oh, yes, of course. Anybody who's listening is welcome to use that anytime for any comments or suggestions or anything. So thank you all for another great conversation. And make sure that if you're listening, that you're following RChain on Twitter and you're subscribed on YouTube. And we will talk again next week.
Thanks, everybody.
Thank you all.
Thank you.